let's start with a quick review of the last lesson. It was about atoms. We're going to give a quick review. Atoms have a nucleus, and then they have electrons that orbit the nucleus. The protons have a positive charge, the neutrons have a neutral charge, and the electrons have a negative charge. And by pushing these electrons out and through a conductor is how we produce electricity. And conductors have 3 or less electrons in the valence shell, and the valence shell is the outer shell where the electrons orbit. They produce a freer electron that is able to escape easier, being as they're in the outer shell. Now, conductors have 3 or less electrons in the valence shell. Semiconductors have 4 electrons in the valence shell, and insulators have 5 or more electrons in the valence shell. Today's lesson will be about voltage, current, power, and resistance. Those are the 4 components that make up Ohm's Law. Ohm's Law is extremely important. It's something we really need to learn. We will start with voltage, and voltage is defined as electromotive force, or EMF, and it is called the force that causes electrons to move through a conductor. The unit of measure is a volt, and the symbol used in Ohm's Law is E. The second component of Ohm's Law that we're going to talk about is current. And current is defined as the movement of electrons through a conductor. It is measured in amperes, or amps, and the symbol in Ohm's Law is I. The next component we're going to talk about is resistance. And resistance is a property of a material which causes it to impede or resist the flow of electrons. It is measured in ohms, and the symbol that you will see in Ohm's Law is R. The last component in Ohm's Law that we're going to discuss today is power. And power is the rate at which work is done. The unit of measure is the watt, and the symbol for Ohm's Law that we will use here is P. Every once in a while you will see someone that uses W, but the mainstream is P for power. If you remember, I told you there were some things you needed to memorize. Well, everything you need to memorize is on this particular graphic. You need to learn that there are 4 names associated with Ohm's Law: voltage, current, resistance, and power. You need to learn their unit of measure, which is volt, amp, ohm, and watt. You need to learn the symbol, which is E, I, R, and P. Ohm's Law is basically 2 formulas. E equals I times R, which is voltage equals current times resistance, or P equals IE, which is power equals current times voltage. Any other form of that can be derived by manipulating those 2 formulas. But this is the one page you probably should learn and memorize. Ohm's Law has 2 basic formulas. The first one is E equals I times R. The other one is P equals E times I. And from those 2 formulas, you can derive many other formulas, and Ohm's Law wheel seems to take care of that. The inner circle shows the thing that you're looking for. If you look, you'll see I, E, P, and R, which is amps, volts, power, and resistance. And that's the thing that you're looking for. And outside of that, it shows the formula for solving that if you know two other components. So you have to know two of the components in order to find the results. Ohm's Law wheel is fairly simple to use. You should be able to catch on really quick. These formulas are really handy for a lot of things. We use these formulas almost daily if you're in the electrical field.
Now that we've done all the definitions, we know what voltage is, we know what current is, we know what load is or resistance, we know what power is. So let's see how all of those work together in order to make an electrical circuit. And we're going to do that with an analogy. We're going to start with a couple of graphics. The first one is going to be a hydraulic system or water. In this particular case, we'll talk about water. And let's look at the first graphic. So here's the first one. Let's look at the first graphic, and the first graphic shows us a hydraulic system which has a pump with a pipe, and water flows through the pipe, and then we go to a valve, and that valve can stop and start the flow of the water. After the valve, we go to a high pressure spray. We're going to say that this is a dishwasher or a car wash or something like that maybe, but in other words, it has to be the place where the work is done by the high pressure. And then the water is sprayed into a tank, and a collection tank, and after the tank, the water flows back to the pump through a pipe. And this is called a closed loop system because there is no external water coming in and there's no place for it to go out. So it's a closed loop system. And then we have a differential pressure gauge, and all that does is measures the difference between the pressure at the top pipe and the pressure at the bottom pipe. Now let's look at an electrical circuit that would be similar. Alrighty, we're going to say that the DC power supply is the same thing as the pump. It supplies the pressure that pushes the electrons through the wire. And again, as the water flows in the pipes, so do electrons flow through the wire. Only it's called current in the wire in an electrical circuit. And the pressure is called voltage. So the voltage goes up from the DC power supply, it goes through the switch, and again it starts and stops the flow of the current, or electron flow in this case. Then we go from there to something called the load. The load is where the voltage is dissipated. In other words, it's just like the spray nozzle. It's where it uses up all the pressure. So when the current comes out the bottom of the load, it has no pressure. Therefore, it is no voltage, so there's zero voltage potential from after the load back to the DC power supply. And then the voltmeter would measure the difference between potential in the top and the bottom. Let's just say we've got a 24 volt DC power supply here, and the voltage potential on the top wire would be 24 volts. The voltage potential on the bottom wire would be 0 volts, so it would measure 24 volts potential difference between the two. So just remember, voltage is the same as pressure, current is the same as flow, load is the same as the work done, and power is the combination of voltage and current.
An example of how this works with formulas is we'll start with the basic formula E equals I times R. Let's say that you know what the voltage is, which is E, and you know what the current is, which is I, but you don't know what the resistance is. Well, the formula E equals I times R won't solve that. There are two really basic algebra rules you've got to remember for this. The left side of the equation is always the same as the right side of the equation, or either side of the equal sign. And what you do to one side, you must also do to the other. So the way we would solve this particular problem is we would start with the formula E equals I times R. And we're trying to solve for R. That's the thing we don't know. But we do know voltage and we do know current. So we will start by dividing both sides by I, which is the current, because we've got to get the R by itself. The only way to do that is to divide both sides by I. So if we do that, the I's on the right side of the equation cancel out, and that leaves us with R. And since they are equal on both sides, you've got E over I equals R. If you flip that around to R equals E over I, then that is the solution to that particular problem. And all of the others are done basically the same way. If you really want to know how each of these is done mathematically, I do have that, and we could probably get it to you if you request it. So that's how you work with Ohm's Law.